Introducing Whitey. Now, I guess we will call this the Whitey lecture. It's the name of my dog. He's a Jack Russell Terrier. He was found pretty bad state. He was abandoned, fell out of a car in the Sonora area on Labor Day weekend. A lot of people go up to Pinecrest during that period, and obviously, well, he fell out with his brothers and sisters, and a bunch got run over, and he didn't. So I got him, and it's mine. They're very smart dogs. Some of the smartest. Look them up if you have time. Okay, so today we're going to look at the following. We're going to look at what we set up as peripheralities. Now, let's forget all about the duck rabbit. Let's pretend for just a moment. Let's pretend for a long time, because we will later be able to extrapolate and extend where you won't have to pretend. Pretend that there's a duck rabbit illusion where you switch your eyes and register it. Duck or rabbit. For aspect seeing, for every possible animal, and it represents every kind of behavior that we have yet classified for animals. And we've classified a lot. Now, we'll start with the Bayesian model. The Bayesian model for neural networks is interesting, and it is helpful to us. But it is not nearly sufficient. And in the direction that it takes it in not being sufficient, it is not helpful to us. It may be necessary, but it is not sufficient. Now, first of all, if you look at a Bayesian model of cognitive neural networks for artificial intelligence, and for the modeling of how cognition works, well, you have objects and features. So they will have for example, they will have a certain kind of rock, yeah? And then and that's the object. And then in this matrix, so this object, you have an object here, rock, and then you have a characteristic up here, and it says lead. Same thing goes for organic, I should say, yeah, that is inorganic, but same thing goes for living materials, such as dogs. But then they go all the way, from color to this to that, but then they go down to the cellular level of phylogeny and stuff like that. It has never been my thing, so I don't know a lot about that. But you're going down to nutrient levels, all of these levels to identify the particular, to designate this particular object. It's sort of a tautology, because all you're doing, you have an object, and then you're sort of, the problem with Bayesian models is that, one of the problems is that you're already working on a confirmation bias. Because you have the object here, and you're figuring, I can establish all of the characteristics for it. Well, sure you can, but Wittgenstein said that in the Tractatus. For every atom, there is an atomic expression, and we can, through the totality of combinations, we can set up all possibilities and then identify individual objects. but he said in the end, this very statement is a tautology because it doesn't say anything about action. It's a model, but that's not the problem. It doesn't say anything about action. And that's what he complained about later. And he said he thought that he had solved all philosophy by saying that all philosophical statements are tautologies. Okay? He saw true functional logic in the Tractatus as simply a method of verifying scientific statements, and thus came positivism, Reichenbach, and so on. Now, of course, he saw later the problem with that. He saw that there is real behavior in the world, and we can't reduce everything to truth functions and say that in the end, anybody who has understood me will let go of the latter and let everything else that exists just pass over in silence, because we can say no more about the universe. And then he changed his mind. Sort of like Brian Wilson did. This is one of his masterpieces. Gershwin's successor. So he put out philosophy for a long time. He just went away, yeah. And he came back, and because he had been keeping notes on a little card that he would keep in a box while he was designing beautiful architecture for his sister. His name is Whitey, not for any racist reasons, simply because of the whiteness here. Good boy. Automatically came to me. So he came back and he looked at language games and human behavior and communal behavior with respect to what he was doing in the past. So what do we want to get at? Let's just get right at it, okay? So he was later doing by Bayesian models, in the same way that the people who are doing neural networks are doing it today. You know, you have an object and you designate all its features, all possibilities, but it's a self-confirming exercise because you know that you can theoretically find all of them. But this is a problem that Turing had. You can't stack forever, you know. You can never find all of the characteristics. So you end up in recursion, and that's where these people will end up. You have to recursive down to the next stack. So you have an index that relates for the other one to go up, but like an irrational number, that becomes transfinite. Now, what we want to get to is, but Wittgenstein was not stupid. The people who are doing AI and neural networks, they aren't stupid either. In fact, their IQs are probably astronomical. I've watched their lectures, but they're mistaken. They're stating tautologies. So, just as Wittgenstein did, and he changed his mind, he said, we aren't dealing with tautologies in real life. We're dealing with possibilities that exist with respect to behavior. Okay, behavior. Actions, acts. So, and he connected the duck rabbit to language and to statements, assertions, and different speech acts with modality in them that have shades of aspect over them, because they can say, you will go, right? Is that an order, or is that a prediction? It can be either. Now, if you compare Slavic languages to the English language, well, you can have the present simple in English and translate it literally into Czech, and it can carry many different tenses. Yeah. And if you want to translate it perfectly from the English, you have to choose which tense, and you sometimes have to modify the tense to get the little translation, and then you have aspect, okay? That presents us with aspect between the languages. So that is aspect. When you have two different families that follow the same rule structures, i.e. language. You have a tense, let's say you have a tense in one language, you have the same tense in the other language, but it's not in the present simple, it's in a different tense. But you're still stating the same thing. And if you want to get it into the right meaning, you have to fool around with different tenses in Russian or Czech or Slovak until you get the precise meaning. You will have to add maybe the word tomorrow on there, saying, you will go tomorrow. Now, that is some evidence of it. I would like to have better examples right now, but I'm not prepared. I order you to go. That is not the same as go. So these things in the background, we have these tenses in the background that are aspects. Actually, tense is an aspect, each tense, but we have these in the background. So we say go. Is that an order? Well, I'm telling him to go, but I may not have the authority. Now, I probably don't if I say go. But if I say that's an order, I'm not ordering you. I'm stating that it's an order. I say go. That's an order. So you modify it. And you do the same thing when you're taking sentence X with an X bar relation. Take X bar in language. Take sentence X. Take sentence A with X bar in English. Take sentence A translated into Slavic, a Slavic language, with X bar. And you won't have the present simple. You have a different tense. Or you may have the present simple, but you'll need to modify it and say things like tomorrow. So these are the shades of aspect. Now, moving on. Now, objects in Bayesian, neural networks. Okay, objects for one thing, if you read Austin, who was at odds with Wittgenstein, but they actually weren't. Julian Boyd and John Searle later figured that out. But he simply said, well, now, all of the philosophy, we've been mixed up all these thousands of years. All of our philosophical inquiries are just games that we like to play with, because we can use meta words like feature. We can use meta words like object, but actually an object is always a noun. A feature is always an adjective, okay? A feature is always an adverb. So everything we talk about, the properties of something, the features of something, what kind of object something is, well, we just need to define the number, which adjectives apply to that particular noun. And we may want to list them, but we don't need to call them features because it works fine when you're speaking in everyday language, but to formalize it, over-formalization, features, objects, no. You've got nouns, and our features are adjectives. Red. The dog is not red. The dog is brown. I have a subject, which is my dog here, and I have an adjective, brown. Of course, I have an object, which is also my dog. But all objects that we're speaking of are reducible to nouns. Moving on. And so, when you look at that, and you look about what I just said with respect to aspect, think about this. The Bayesians don't connect it to language at all. What Wittgenstein did, He didn't make matrices, we are. Okay? So we have herds. Okay? Okay, fine. We have herds for different categories of animals. Okay? And I don't want to lose aspect, but just assume that when I say bison, it does have an aspect to it where maybe the bison can also be seen as a duck. Okay? Let's take a non-herdish behavior. Let's say that a rodent, maybe they're diggers or something, I don't know, there's certainly a name for them. Or let's take scavengers or whatever, yeah? And still say that you can see it also as a duck, okay? See what I'm saying? So just assume that there's an aspect for every animal that exhibits behavior. And that there's aspect for it, and that we have a peripheral, like herd, or it's an animal that goes in troops, or that flies in flocks, yeah, okay. And you have the peripheral for one part of that, and you have the peripheral for the other part. Now the thing is, let's look at it this way. When you have herds, so duck, rabbit, herd, or if I can do it, bison, rabbit, if I could have such a picture, okay? Bison, I switch to bison from duck, and I see herd. Well, now herds are interesting, okay? Herd mentality is interesting because this hits not just to the word herdish, but it hits to the actual look and patterns of the behavior itself. And we're going to see something here. So, what happens in a herd? It's in economic theory, it's in all kinds of theory, game theory, and so on. But we've never touched it like this before because we're touching aspect and language and herd and counterfactuals where they're intimately related and so on. So, a herd generally, you get the herd mentality when a bunch of bison are being attacked, right? And it sort of looks like it's a non-angular polygon, 4 sides. Not orthogonal here, but it has 4 sides like this. But there's always a weak point. There always has to be a weak point, otherwise they wouldn't be coming into this particular herd mentality. I mean when they really exhibit herd mentality, not when they're going in a herd without threat. But when there's a threat, they go into herd mentality. And somewhere, usually down on the bottom someplace, okay, there's an area where the attack comes. So you have I'll put a link to this because it's shown. I'll put a directional link to this which shows a moving JPEG or whatever. So the attack, so you have this thing here, okay, this herd, and you've got this little area here, yeah? It's open, it's vulnerable. So that's where the attacker always goes to, the lion. He goes here, boom. What happens to the herd? It goes, There's a big wave. It comes, and the gap gets a little more shut, so it's less vulnerable. It goes, but the lion still comes. It goes, boom, and then the wave is there, but it's less of a wave. It's getting straighter. Okay, does it again, and you're almost straight, but you're never straight. And what's that called? That's called asymptotic. There's a limit. Okay, you have this when it hits, draw a line. This, when it hits, draw a line. It's like that. Okay, hits again, draw a line. Okay, lesser line, because you can see them moving at different stages of the hit. And the last one, just draw a straight, don't draw a straight line, just do it, I've done it on my computer with some pictures and stuff. Now, but I don't like showing these pictures. I expect you can imagine them. So, so what happens when you get this this thing, but it's just like that. For one thing, it's asymptotic, meaning there is a limit to which you can go, okay? But you can never get to a straight line. There will always be this vulnerability until that jerk of a lion, which we love for their own purposes outside of this, but they must eat. But anyway, until the lion goes away, yeah? Okay, but what's happening right down here as long as the lion's attacking? This is symmetry breaking behavior, okay? Normally a thing will look like this, okay? But if a thing has a vulnerability point, that is obviously a vulnerability point because each time it gets hit, if you just take this, yeah? And you don't see a vulnerability point, if something attacks it, automatically there will be a vulnerability point and the thing will do a wave, okay? Okay. And that creates symmetry breaking. Symmetry breaking is very interesting and we will go into that later. Now, what happens, why does it get more and more less vulnerable the more times the line hits? Because nearest neighbor, there is in game 3 this thing called frog jumping. I bought my son this a long time ago. So each time that the thing hits, okay, that the lion hits, these bison, not because they're smarter, but because it's behavior, maybe they are smarter, but they get closer and closer to each, all around the perimeter. They get closer and closer to each other. It's called nearest neighbor. Your nearest neighbor. Okay, so here we have some frogs. I'm using the simplest game. I don't like the game. But anyway, so how do they get to the nearest neighbor? So the rule is, I jump a frog, I can put him in here. Okay, so that's what happens with the bison. Okay, now I jump a frog, I can put him in here. So you see, they're moving out of the danger part of the danger zone, or the danger state, the state of danger, into a less state of danger, but still in the same herd, right? And here's the last one, I can put him in here. Here's the last one, and I can put him in here. There's always one left, okay? So now I have nearest neighbors, and that's all around the perimeter, right? Okay? This guy here, we're not going to talk about him right now. I'm not sure about him. I have some thoughts about him. We'll leave him for later. He might be the... doesn't matter. So, now, with respect to even what the people who propose neural networks with these Bayesian models,